Hello Rahul. Before you
Yes, sir.
start, can you please tell me the name of company you are applying for and the subject you are preparing for?
MRPLs basically, and the subject is heat transfer.
Okay. Okay, Rahul. My first question to you: what is thermal conductivity?
So thermal conductivity is a property of a material by which the heat is transferred. Basically, if thermal conductivity more, then heat will be transferred and will be more. So basically, it is a intrinsic property of the material which decide the heat transfer rate. Like solids is having like metal is having more thermal conductivity, and insulator is having lower thermal conductivity. So heat transfer within that, like conduction will be less in the insulator, and if high conductivity is there, then conduction will be more.
Okay. Okay. What are the different heat transfer mechanism you know?
Different heat transfer mechanism is conduction, convection, and radiation.
Okay.
Mechanism, yeah,
Conduction, convection, and radiation. Right.
radiation, yes, sir.
Okay. Anything else?
Uh,
Can you elaborate those
yes,
mechanisms?
sir. So conduction is basically transfer due to the molecular vibrations. So
Okay.
within a bodies, and conduction basically occurs due to the density difference, or like some driving force, and radiation that doesn't require any medium, and it can be transferred uh, at any at any medium, like without medium also. So radiation is basically, we can say, the light radiation that is coming from the sun, that is due to the radiation only. And conduction basically, that occurs in base solids. So that was the behavior shown by the solid, and liquid is having lesser conduction, and convection is more in liquid, because when we heat it, then there will be some density difference, uh, temperature difference will also be there. So this higher density liquid goes to the towards the lower
Okay.
density
Okay.
difference.
Tell me
So
how conduction occurs in a solid and in gaseous state.
how conduction occurs in solid and gaseous state.
Yes.
That, acha. So conduction, na sir?
Yes. Yes.
Conduction.
The conduction
Yeah.
mechanism only.
So conduction is higher in solid, and this conduction occurs due to the molecular vibration. So basically, if uh, more molecular momentum will be there in a body, then it will have more conduction. But in the gaseous stage, uh, the molecules are moving. They are, when we provide a temperature, so they are not having any intermolecular collision. Oh, no, sorry. They are not having any molecular vibrations, so they are not having any
ओके
so
और
that was
सॉलिड में मोमेंटम रहेगा किसका मोमेंटम रहेगा
momentum, sorry, molecular vibrations we call.
अच्छा
Hmm.
ओके ओके व्हाट इज एमिसिविटी
The emissivity, that emissivity is the property of the body by which it emits the energy. When any energy comes to any body, then it reflect, or it gives some, it reflect the energy, and after absorbing that energy, it goes from that environment. It emit that energy to the environment. It's called emissivity. So it is basically the uh, emissive power of a body to that of the emissive power of the black body.
एमिसिव पावर ऑफ ए ब्लैक बॉडी
Yes.
अच्छा और एब्जॉर्बिविटी क्या होता है
absorptivity. So whatever text, matlab when energy comes, or when energy is directed towards the object, it absorbs some amount of the energy. The fraction of the energy that is absorbed, that is called the absorptivity.
ओके, अच्छा। किरचॉफ्स लॉ ऑफ रेडिएशन पता है?
Kirchhoff's law of radiation. Uh, Kirchhoff's law said that the heat transfer takes place according to the fourth power of the absolute temperature with the body of the body. Kirchhoff's law.
ये किरचॉफ्स लॉ है।
Yes.
अच्छा, ठीक है। ओके। हीट एक्सचेंजर क्या है? व्हाट इज हीट एक्सचेंजर?
Heat exchange basically transfer the heat between the two liquids or two fluids, we can say. And like there are two types of, basically if we say there are two types of the heat exchange, direct and indirect types. So the direct, it may involve some mixing, but in indirect, there will be some medium like any heat exchanger. So that will transfer the energy from one fluid to the another fluid. So the basic example is double pipe heat exchanger for the indirect type, and double pipe heat exchanger contain the two liquids, which one will be one needs the heating and one will be the cold fluid. So the heat is transferred through that heat exchanger
अच्छा, अच्छा। हीट एक्सचेंजर को क्लासिफाई कर सकते हैं बेस्ड ऑन इट्स ज्योमेट्री?
based on a geometry. Number of passes. So like one, two passes cell and if we take the example of cell and tube heat exchanger, then if we take the example of cell and tube heat exchanger, then if we take one passes, so that means one pass for the cell and one pass for the tube. If we take one and two pass, then two passes for the tube. So basically the tube liquid will pass two times in that heat exchanger. So it is according to this passes. And uh, another type of geometry like plate type, there are different types of heat exchangers. So plate type was also there. And
ओके, ठीक है। अच्छा, ये बताइए, कॉम्पैक्ट टाइप हीट एक्सचेंजर क्या है? क्या डबल वाई हीट एक्सचेंजर को कॉम्पैक्ट टाइप हीट एक्सचेंजर बोल सकते हैं क्या?
so, compact type heat exchanger, that is having surface area per unit volume more. So basically in less volume there will be more surface area. So it is used to increase the efficiency of the heat exchanger. And compact type, we cannot exactly say this is double pipe heat exchanger. uh, Compact type maybe having this high surface area in a compact volume, we can say. So that is compact type heat exchanger.
कहाँ रिक्वायर होता है कॉम्पैक्ट टाइप हीट एक्सचेंजर? कैसा ऑपरेशन है?
Like if like if we say in the engines where we need lesser space, like the cars maybe, or different types of the engines that require lesser space.
क्या, कौन सा स्पेस?
मतलब lesser space, that require
लेसर
less
स्पेस?
space. Yes.
ओके, तो वहाँ हम लोग कॉम्पैक्ट कर लेंगे।
Yes.
और ऐसा कुछ क्राइटेरिया नहीं है। ठीक है। साइलेंट हीट एक्सचेंजर कितना टाइप का होता है, कुछ पता है?
Talent use One may cross flow counter parallel, that is according to the flow, but silent tube में due to the passes we can also do differentiate basically. And
और कुछ?
that I don't know, sir.
डोंट नो।
Yes, sir.
ओके। अच्छा ये बताइए, व्हाट इज द रोल ऑफ वेफल्स इन साइलेंट
Baffles.
हीट एक्सचेंजर?
Yes, sir. So that is basically used to increase the support in a cell and also increase the heat transfer rate, but that will increase the pressure and flow. It will decrease the flow rate of the fluid. So that basically increases the heat transfer between the fluids.
So what will be the effect on pumping power due to the presence of vessels?
Pumping power, we need more pumping power because of this baffles, because that will reduce the flow rate, and we need more power to drift that fluid from that when baffles are used.
Okay.
It basically increases the heat transfer area.